In the broadest sense, the place that we are from is the universe. And, according to current scientific theory anyway, that is where we will remain, since while space is vast from our human perspective, there is in fact a boundary to reality, the edge of the universe, beyond which no travel, communication, or any kind of interaction is possible. As the story goes, in the beginning, around 14 billion years ago, the entire universe burst out from an infinitesimally small point, in an event first jokingly referred to as the Big Bang. The name, however, has stuck. Over the next few millionths of a second, the universe rapidly expanded and was filled with an incredibly hot and dense plasma, a fourth state of matter, not solid, liquid, or gas, made up of the fundamental building blocks of matter called quarks, as well as negatively charged particles called electrons. Within the first second, the quark soup cooled enough to form matter as we know it, including protons and neutrons, the particles that together make up the nuclei of atoms. A full-scale simulation to test our theory of the Big Bang requires more energy than we can conceive of controlling. However, the world's largest particle accelerator, the Large Hadron Collider at CERN, smashes things like the nuclei of atoms together at extremely high energies, forming something akin to the quark soup thought to have existed shortly after the Big Bang. Observing these mini Big Bangs gives us some clues about what was happening in the early universe. We've learned that as the universe continued to expand and the temperature and the density decreased, some 380,000 years after the Big Bang, protons and neutrons combined into positively charged nuclei and attracted the free, negatively charged electrons roaming around to form the simplest atoms, hydrogen and helium. As these atoms formed, excess energy was released in the form of photons, the particles that make up light. And with the free electrons out of the way, these photons of light could travel uninterrupted. Before this, the universe was opaque. And then it became transparent as the oldest light in the universe streamed out. Awe-inspiringly, the now cooled remnants of this light are still observable today in the form of the cosmic microwave background. This is as far back as we can see, as these primordial photons arrive at our planet after traveling through the expanding universe for billions of years. We only noticed this backdrop to our universe around 50 years ago. At first mistaken for interference from pigeon droppings on the equipment, the cosmic microwave background was accidentally detected by astronomers Robert Wilson and Arno Penzias. After the pigeons were removed and the new supersensitive antenna cleaned, they realized that the noise they were picking up was actually a signal, and that the space in between stars and galaxies was not completely dark, as was previously believed. In the background, coming from all directions at all times, is a faint signal, an ancient bath of light cooled to just slightly above absolute zero, left over from the formation of matter in the universe billions of years ago. Coupled with our observations that everything is moving away from us and that most galaxies are moving away from each other faster and faster, implying that the universe is expanding at an accelerated rate, analysis of the cosmic microwave background lets us wind back the clock. By doing this, we can estimate the age of the universe, somewhere in the region of 13.8 billion years. Looking at the oldest light tells us not just about when the universe came into existence, but also about the earliest matter. After 380,000 years, the universe consisted of mostly hydrogen and some helium atoms. In fact, the Big Bang is the only process we know of that produces hydrogen in significant amounts in space. Therefore, the water molecules making up more than half of your body contain hydrogen atoms, constituting around a tenth of your mass, that are almost 14 billion years old. Though the beginning of the universe may feel so very far away, there is something magical in the knowledge that we are all bathed in faint, ancient light from the beginning of time, that within each of us lives the entire history of our universe. After the formation of the first hydrogen and helium atoms, clumps of this early matter began to gather under the force of gravity into hot, bright, dense objects. The earliest stars were born. Within the nuclei of the atoms that make up matter, vast amounts of energy are stored. Under the extreme temperatures and pressures in their cores caused by the immense gravity there,